Hello, everyone, and welcome back. In this lecture, I will be going over extensive and intensive properties. And so, in the last lecture, I talked a little bit about density, and so I'm going to use density as an example of both properties, or at least, yeah, I'm going to talk about density and the parts of density to explain these different properties. Um, Extensive properties are properties that depend on the amount of substance you have. So the more substance you have, then the more of this property you have. The less of this substance, the less of this property you have. So a couple examples is volume, right? So the more of the substance you have, the larger the volume you're going to have. So for example, if I have water. So if I have a cup of water or a beaker of water, then if I put enough water into the beaker, it's going to fill up halfway. It's going to take up that volume of the beaker because that's the amount of substance I put in, the amount of water I put in. So the more water I put into the beaker, the more volume it's going to take up in the beaker. So that would be an example of a property that is an extensive property. So the volume of something is an extensive property. Um, Another property is the mass. So the mass of something, right? So if I want to weigh out a cup of sugar or a certain amount of sugar on my balance, then what I do is I put some sugar on the balance. I put an amount of substance, amount of sugar on the balance, and the balance gives me back a mass. So if I put more of the substance on the balance, then I get more mass of the substance. The balance will read a higher mass. So that's another example of where the substance or the mass in this case is going to be an extensive property where the more of the substance I have, the more of the property I have. The less of the substance I have, the less of that property. So both both volume and mass are examples of extensive properties. They depend on how much of the substance you have. Now, what about intensive properties? Intensive properties, or what you might call intrinsic properties, are properties that don't depend on how much of the substance you have. It just depends on the type of substance you have. So, what is the substance we're dealing with? It doesn't matter how much of it you have. What is the substance? So, um, what do we get if we take mass and divide it by volume? If you were watching the last video, then or saw the video on density, you would know this. So that would be right, density. So density, let me, so density is going to be equal to the mass over the volume divided by volume. So what do we have here? So we have a ratio. So we have a ratio of mass to volume, right? So if we are looking at the density of a particular substance, that substance doesn't change. It's always that type of substance. So um, if I have a certain amount of that substance, say water, right? Um, that certain amount of substance is going to have a certain mass, and it's going to have a certain volume, right? And both of these depend on how much of it you have. So if I take that and put it into a ratio and divide, I get density. So, for example, the density of water, we'll say, uh, is 1 gram per milliliter. So, what that tells me is that for every gram of water I have, I have 1 milliliter. So it's a 1-to-1 ratio. So 1 gram of water is going to give me 1 milliliter of water. So that's the ratio, 1-to-1. Okay. So this ratio is not going to change regardless of how much water I have. So if I have 20 milliliters of water, then that means I have a certain amount of mass and a certain amount of volume. That ratio of volume to mass for the water is not going to change. It's going to stay the same. So, um, if it's 1-to-1, if I have 20 grams of water, then I should have 20 milliliters of water, and I still get the 1.0 grams per mil, right? So if I double the amount of water I have, if I double the amount of water, what happens to the mass? I double the mass. I also double the volume. So if I'm doubling both, then the ratio stays the same, right? So if I double the mass and I double the volume, right? And that gives me 40 and 40. I still get 1-to-1. That's still going to give me 1.0 grams per mil. So, and you can see that also by, look, I have two, I'm multiplying 2 here, I'm multiplying 2 here. These are divided. So whatever you have on the top cancels with whatever you have on the bottom, and it stays the same. So this is an example of an intensive property. So no matter how much of the substance I have, this property stays the same, density stays the same. This is one of the reasons why we can use density to identify the substance we have, because different substances have different densities. So if we can measure the density of the substance and we can look at a list of density values of known substances, we can figure the unknown out. So that is a good introduction to the distinction between intensive properties and extensive properties. I hope you enjoyed it and learned a lot, and come back next time. See you later.